Increasing the electrical potential of the H2O molecule.
Yeah. Real quick on that, because I was having this conversation earlier, and um, the term is out there, I believe, right? Vitalized water. There's other people, companies that use this term, but it's not exactly the same as how you have created vitalized water, or what true vitalized water is. Is that correct?
I'm not sure if that's correct. I personally, by the way, I do not like the word vitalized.
Okay.
And I tend to use what I just said. I tend to say increasing the electrical potential, but that's a mouthful. And some people might not even know what that means. But another point, well, I'm getting a little bit off topic, but you might want to know this too, is that anything to do with water in the science community is usually disrespected.
Hmm.
Gerald Pollack, and there's other people that work with water. Um, it's a very tough sell. Jerry warned me. He said, if you're going to go down the road of water, good luck. They're going to kick your ass. It's completely misunderstood, and most scientists, physicists will say vitalized water is ridiculous. And just talking about anything to do with water. They just say water is water. There is no
Hmm.
changing the water
Yeah.
other than filtering it. So along those lines, the rest of the world, well, I shouldn't say the rest of the world, but the term vitalized
Hmm.
is it's considered woo-woo. It's considered mysticism bullshit.
Right. Pseudoscience.
Pseudoscience. Yep.
Yeah.
Oh, just so you know, I don't know if you know this, but
That's what I was kind of getting at is yeah, I think that term might be used a lot loosely or thrown out there, but it's not totally accurate to what you're describing here as vitalized water.
that's yes. So from that point of view, you're right. When I say vitalized, I'm specifically referring to increasing the electrical potential, and that could be measured in a voltage.
Gotcha. Okay.
So, and I've kicked around all kinds of other terms instead of
Hmm.
vitalized, but I can't come up with one that fits. So I keep using vitalized.
Yeah. Okay.
One of the big things for me, actually, it's a massive thing for me, is the fact that we can quantify this. No one else,
Hmm.
as far as I know, can really quantify it, both in terms of increased voltage and increased, or I should say, decreased resistance. Are you familiar with ohms?
Hmm.
So it's if we increase the voltage, we're also decreasing the resistance.
Hmm.
That's a big thing. Think of nutrient uptake for a plant, or any time there's a least resistance. Think of when you're arguing with somebody,
Uh-huh.
but they don't really provide so much resistance. It's a great argument. You know what I mean?
Uh-huh. They're more
Resistance,
receptive to what you're
yeah,
trying to
it
say. Yeah.
it turns into a discussion rather than an argument. In physics, resistance and engineering, whatever, resistance is a very important topic. So higher volts, lower ohms, you
Hmm.
know. As far as I know, no one in the world is measuring the voltage of their so-called vitalized water.
Hmm.
Um, Not a whole lot of people are have much data on biomass and nutrient density. So
Hmm.
that's another thing that I'm putting a tremendous emphasis on is from an agricultural point of view, more biomass, more nutrient density. So all of these things help give credibility to the term vitalized.
Yeah.
Another thing, just so you know, the higher the voltage of the water, the which is measured in the exclusion zone, you also tend to get a thicker exclusion zone.
Hmm.
So think of desalination. If we have normally, Jerry Pollack would say you can get somewhere around 400 to 500 micron thick exclusion zone. That's a half of a millimeter. But imagine if we could increase the voltage even more. I think we're going to get, let's say, a 1,000 micron thick exclusion zone. That's 1 millimeter. So the higher the voltage, the more likely, the more effective will be desalination, hydrogen, and of course agriculture, all of that.
Yeah. Yeah, so real quick on exclusion zone, if you could define that again. And
Yeah. Exclusion zone. So Gerald Pollack, University of Washington, discovered this very important property of water. He calls it the exclusion zone, and I'll tell you why in a minute. But it's when light, visible or infrared light, comes in contact with water,
Mhm.
and if there's some type of hydrophilic surface in the water. Hydrophilic is water loving or water attracting.
Mhm.
Hydrophobic is repelling water. Like my hair is kind of dry, or water
Uh-huh.
just rolls off of it, so it's hydrophobic.
Uh-huh.
So light, water, and hydrophilic surface, those three things come together, nature automatically forms H2O will convert to H3O2.
Mm.
This is a big discovery, very important discovery. All along the surface of some hydrophilic surface, layers upon layers. Jerry estimated maybe as much as 100,000 layers of H3O2 form on this hydrophilic surface.
Mhm.
H2O converts to H3O2 in the form of a hex. So you get these hexagon sheets,
Mhm.
one atomic layer, hexagon, and then another one that is overlaid on top of it, but it's a little offset. And then the next one, a little offset from that, and so on and so on and so on. 100,000 layers of a crystal. It's a liquid crystal.
Mm.
So it's the reason he calls it the exclusion zone is because this hex layer, these hexagon layers are so dense and pure. It's purified. There's nothing else but hydrogen and oxygen there. So it pushes out, it filters out all other particles. It excludes everything.
Mm.
That's why he calls it the exclusion zone. And I've seen it under a microscope. I would turn the light on and I would see it forming. I would have, let's just say this is my hand is the hydrophilic surface, and all of us, and there's a vial filled with water here. It's just H2O, but you turn on the light, um, or heat, a little bit of heat, infrared or visible light, and you can literally, and if I put a drop of microspheres in the water,
Hmm.
so those are microscopic suspended particles, but
Mhm.
it looks like a liquid to the naked eye because these particles are so small. But I'll just put a drop or two, and the whole thing, and it mixes up. The whole thing looks like a little bit of cloudy water. And under the microscope, you can see individual microspheres.
Mhm.
So, so I turn on the light, and sure enough, right along the hydrophilic surface, I see a bunch of microspheres until you just give it a couple of seconds, maybe 10, 20, 30 seconds, and you start seeing them be pushed away. So they push away as far as 500 microns.
Huh.
So once you look into that H3O2 zone, the exclusion zone, there are zero microspheres.
Hmm.
So it excludes all those particles and it pushes them back into the regular amorphous H2O.
Yeah. Interesting.
So
Almost like
another,
would an analogy be like the membrane of a cell or something, like the outer wall of a cell? How?
well, it's interesting you say that because Jerry wrote his first book called Cells, Gels, and the Engines of Life. This is
Hmm.
before he discovered the exclusion zone, and he was proposing his background is biophysics. So he was proposing that there's some type of structured membrane. He didn't call it the exclusion zone, and he didn't know it was a hexagon layers, but he said there's some kind of a new phase of water forming here. It's
Hmm.
not gas, it's not liquid, and it's not solid, it's not ice. It's a liquid gel that is
Hmm.
semi-permeable.
Hmm.
Depending on the voltage, there are properties that you can give to the exclusion. Well, he didn't call it the exclusion zone, but there are properties that allow transference or semi-permeable or not, blocking off when you need to, let transport happen when it needs to, let it push things out when it needs to.
Hmm.
So he was proposing all this in that first book, The Cells, Gels, and the Engines of Life. Then a year or two later, he discovered formally the exclusion zone and he realized, oh my God, that's exactly what's happening in the cell, is what you just asked.
Yeah. Huh.
So it comes down, let me just say, in that exclusion zone, that 500 micron area, it's a negative charge.
Hmm.
The rest of the amorphous or the bulk water is what he calls it. It's a positive charge. There's a voltage right there. So as soon as you separate that's the definition of voltage, by the way. It's difference of potential.
Hmm.
So as soon as you separate H2O and H3O2, you get a difference in potential. You create a voltage. And in my opinion, and also in Jerry's opinion, this formation of the exclusion zone is the source of bioelectricity.
Hmm.
No one knows where that comes from. They don't know how our bodies generate bioelectricity. So
Yeah. Interesting.
I'm saying it's from water.
Yeah, I mean, makes sense if we're what 95% water.
If
If you
you
look
if
at
you
each molecule in the human body,
it's closer to 99.
90. Wow.
If you measure the volume of our water in our bodies, it's 60, 70%. People say roughly
Right.
two-thirds by volume. However, by number of molecules, it's 99%.
Yeah.
The water
Huh.
molecule is so small compared to almost all other molecules.
Yeah.
99% we are water. So it brings up all kinds of questions around the prospect of EMF, at which reduces the voltage in water. So if we're walking around in EMF smog, we're diminishing our bioelectricity, which goes back to the spiritual foundation program, where the chakras are trying to hand off energy to the crystal palace, and then the crystal palace sends energy to our nervous system, and that's where the voltage, bioelectricity voltage starts.
Yeah.
So if that's in question or compromised, if our bioelectricity is diminishing, we're opening up potential for inflammation, and that's the primary root cause of all illness.
Yeah.
But even worse, in my opinion, you're disconnecting from spirit now.
Hmm.
The chakras are trying to send energy into the crystal palace sending it to the nervous system. And if that can't make a proper connection, our spirit is dying, our consciousness is diminishing.
Yeah. So back to exclusion zone. I want to stay on topic here.
Yeah.
Is there any hypothesis as to like why this is happening? Is it just because there's some intelligence in water, or like has Jerry come up with a hypothesis, or on why the exclusion zone is forming like this?
This is just one of the mysteries of nature that is being discovered.
Yeah.
It's
Huh.
kind of like saying, well, see, I'm about to go on a possible sidetrack here too. I won't go too far except to say, think of similar with Magneto.
Hmm.
I mean, I know we're not talking about that right now, but it's in a similar way. There are secrets to be uncovered. I
Hmm.
think Magneto is going to start uncovering ratios in terms of like the size and mass of atoms compared to the Earth,
Hmm.
and harmonics in
Mm.
between. And so we start to unlock stuff like that, and it turns into scalar, the discovery or the validation of scalar waves. I don't know if you're
Uh-huh.
familiar with
Little
scalar
bit.
scalar
Yeah.
vibrations. Tesla, I think he may have been the one to introduce scalar. But anyway, it's similar to the exclusion zone. There are there are secrets, there are harmonics, so to speak, just waiting to be discovered.
Yeah.
So if you think of the electromagnetic spectrum, visible light, which is only a tiny part of the spectrum,
Hmm.
and then a little bit lower frequency is infrared. So that range right there happens to be the consonant, or we could call it harmonic range,
Hmm.
to change the chemical composition of water.
Hmm.
But if you go just a little bit down that into the microwave range, before radio, but after infrared, that's where microwave is.
Huh.
That specific range, which was chosen, no coincidence for wireless communication, that specific range diminishes the voltage of water. It prevents exclusion zone formation.
Huh.
So if you think of it like a bell curve, there's a not X-rays, but ultraviolet, well, a little bit into the UV. That's
Hmm.
where the exclusion zone just begins, but it's weak. But it's like if you think of a curve, but it gets higher and higher as you go through visible light, or I should say a stronger exclusion zone and a higher voltage, and it peaks right at infrared.
Hmm.
But then you start going down in the infrared, lower frequencies toward microwave, the exclusion zone potential or formation is diminished.
Hmm.
So then if you go below a certain threshold, let's say you're down here, now the peak is in microwave where it's like zero exclusion zone,
Hmm.
zero voltage. So you can think of it like a sine wave, like there's peaks and there's troughs.
Yeah. So you never want to microwave your water then?
No,
Okay.
absolutely not. Absolutely not. And the reason is because you're diminishing the voltage. You're intentionally, by microwaving water, it's really not that much different than putting it near a wireless router. The only difference
Hmm.
is heat, but still it's the same frequency. You're making dead water.
Hmm.
That's what you're doing. You're pulling all the electrical energy from the water. Then you go and consume that. And now that resonance is spreading through your body. The
Hmm.
rest of the it's Have you ever seen the synchronized metronomes?
Yes. Yeah.
That's a good that's a good analogy to use here because the surrounding water in your body, if you consume zero voltage water, the rest of the water in your body is going to have to fight against that resonance, and some of it is going to resonate with zero voltage.
Yeah.
It's like if you could imagine sending I don't know what I'm thinking of right now. The color, if the zero voltage water was a different color and you could see an X-ray of that, it would be spreading out throughout your body, not just that water itself, but it would be like transmitting that frequency. So the
Yeah.
otherwise higher voltage water is now being diminished.
Yeah. Wow. Very interesting.
Yeah, very
Okay.
important.
So we've got the exclusion zone. That's light plus a hydrophilic surface. Oh, I wanted to ask, what have you used? Um, like, what's an example of a common hydrophilic surface that you've used in experiments or that you typically use to create the exclusion zone?
Oh, actually, I should know this, but I don't. I don't know what a like a nat. I don't know the best natural or common surface, but I always use something unnatural or manufactured. It's called Naphion.
Naphion.
Yep, Naphion. It was manufactured, I think, for the purpose to make, hydrophilic experimental materials.
Hmm.
So I would always buy
NAF?
NaFiON.
Naphion. Okay.
Yep.
Never heard of it, but okay.
Yep. I would always buy a little Naphion, and that's how I perform my experiments.
Okay. So we've got the exclusion zone, and then, but that's not directly tied to like vitalized water. You can still have an exclusion zone without vitalized water. They're exclusive, right? But
Yeah, they really have nothing to do with each other per se,
mhm,
except I would say if you want to measure the voltage,
mhm,
you need to create an exclusion zone.
gotcha. Yeah.
But for example, though, let's just say you want to vitalize 10 gallons of water for your garden one morning or something.
Hmm.
Um, and let's say you also want to test what it was before and what it was after you vitalized it.
Hmm.
So then I would say now you need to take just a very small amount of that 10 gallons. You only need a couple of milliliters, by the way. I mean, we're talking just a few drops
Hmm.
is enough to to measure the voltage. You create an exclusion zone in some Nafion surface, you just put a little piece of Nafion in a
Hmm.
tiny little vial of water. You add a little water so it surrounds the Nafion. I mean, I'm talking really small pieces of Nafion here.
Hmm.
Um, and then yeah, you positive and negative electrode and a simple multimeter, a digital multimeter, and that's how you measure the voltage.
Hmm.
I like this image. That's a piece of Nafion under the microscope. You're seeing the cross section of a small tube or a small straw.
Gotcha.
And if you can see, like let's say you're
I see. Those
on the
edges around the edges are a little more blurry
well,
of
what
the
you're
tube.
looking at is like let's say right in the middle of the straw, you're looking at microspheres.
Hmm.
And then close along the surface of the Nafion straw or tube, you're looking at H3O2. The microspheres reside in H2O. The
Mm.
clear areas or the non-microsphere areas, that's exclusion zone areas.
Mm.
That's where the negative electrode has to go. You
Gotcha.
got you got around 400, 500 microns of space there. So if
Like
you can
so
carefully
what is that?
half a
Half a
millimeter.
milliliter. Yeah.
Yep, yep. It's visible to the naked eye actually.
Hmm. Okay.
So yeah, if you can sneak a negative electrode in there, and that when I say that, all I'm talking about is a thin copper wire. That's what I use. I just I just scrape off the end of the insulation. Those copper wires, they're usually coated with a polyurethane insulation. You just scrape it off with a little bit of sandpaper and stuff it into that exclusion zone area.
Huh. Okay.
And the positive electrode goes into the H2O, wherever you see the microspheres.
Yeah.
And that's it. And you hook it up to a multimeter and you got the voltage and the resistance. So it's fairly simple.
Yeah. Interesting.
But another thing I want to work on is a commercially available exclusion zone, a water voltage reader.
Yeah.
So people wouldn't have to go through this process that I'm just described to you. They just have a little handheld device, put a couple drops of water in it, and see the digital readout of the voltage.